welcome everyone. So this is actually a hands-on workshop. If you would like to follow along, we have prepared some resources to you. So yeah, open up, you have a laptop, open it up and go to this. You might have to type this manually because I don't have a way to share you this long link. Yeah, but this link will take you to an AWS Workshop Studio page where it already has the entire environment provisioned for you so that you can run a lot of the content that I will be showing in this workshop. Yeah, we still have about 5 minutes before we get started. So if you are interested in doing hands-on with me, go ahead and follow that link. Yeah, so this workshop, the resources will be available until Saturday, sometime tomorrow. We're also recording a video here. And yeah. You can start it now and come back later, yeah. But just make sure to take a picture of this, at least, so you can go to access the resources and also access the website that has the workshop materials. Oh, also, are you able to see the screen when I'm standing here, or is it kind of, you have to, 30%? Do you maybe sit on, take that spot or somewhere in the back so it's easier to see? Okay. Yeah. I have a business card. Can I get that? Okay. Yeah, sure. That's me. Contact. Mm-hmm. Hey. No. It's free. It's provided. I worked with the AWS team. Vinny right here from AWS. He was so kind enough to help me provision all these resources for all of you today. So yes, please take advantage of it. So when you go to this link and sign up, you just need to enter in your email, and then you're going to get a one-time passcode sent to your email. You already have an account. Just sign in with an email. It doesn't matter. Yeah, so this workshop, you can use your own AWS account, but it's going to be charging your account money. If you use this workshop studio, it's on AWS. So please take advantage of it, because we are using some computing resources that charge us I think $12.60 an hour. I don't think you want that running for too long. Saturday, yep. Oh, Sunday, yes. Yeah, it's available. This will be available until Sunday. So in case what was that? Well, it's sent to your email. Okay, does anyone still need this link if they want to do hands-on? For the folks who just joined the room, so this is a hands-on workshop, but if you would like to do it hands-on together with me, follow this link right here. Unfortunately, it's a very long link. Maybe. It's the one-time passcode sent to your email. Oh, maybe I should have created a bit URL or something. Yeah, that should be the page. Yes. Oh, so just to let everyone know, if you are able to log in, you should get something, a page that looks like this. It's not working. One sec. Oh. I will say we will be doing a lot of copy and pasting of commands. So if you can do it on your phone, I just don't recommend it. But good luck. Yeah, because I'm going to have to be switching back and forth between the tutorial and also like a console terminal, just because I only have one screen to work with right now. All right. Ask the event organizers. We are recording the video right now, actually. How to get it. Ask the event coordinators. Yeah, and for those who joined the room recently, the workshop studio URL, like it already has provisioned AWS resources for you. That will be available until Sunday. So even if you're not able to get through everything today, you have the next couple days to go through it yourself again. And all the tutorials are there. You can also go to opea.awsworkshop.io if you want to run it on your own after the workshop studio is not available anymore. All right, so I'll give maybe 2 more minutes for everyone to get that set up. Does anyone have any issues logging into the page? So upon successfully logging in, you should see a page that looks something like this. Yeah, so what's really cool about using Workshop Studio is that the entire environment's already provisioned. If you were to set up the environment yourself, it takes like 30 minutes. So we don't want you to do a workshop and have to set up your own environment. Yeah, provision can take a while. But I'm counting the number of people in this room. We have 40 of these available, so it's going to be first come, first serve. All right, does anyone need more time to log into this page? Are you counting the attendance? Let me know how many are there. Okay. All right. So when you get to this page, what you want to do is click on this Open AWS console. And when you open it, it takes you just like as if you logged into AWS. Yeah. So if you're able to get to this point, then that's how you know you're able to access the resources. All right. So for this workshop, I'm going to be covering how you can build GenAI apps on AWS using Elastic Kubernetes Service, CloudFormation, and also how you can build using an open source project called Open Platform for Enterprise AI, and how you can customize it to use a lot of different AWS services, including OpenSearch and Bedrock. All right, so let's get started with Module 1. So Module 1. So just as a curiosity, how many of you are students? And then how many of you are developers? Most of you. And then how many of you are managers or business decision makers? Okay, so I think we have a very good spread, very evenly distribution amongst all 3 of these. Okay, This one will be tailored towards more for developers because it's actually using AWS to build GenAI applications. But for people who are managers and business decision makers, I will give you some of the takeaways about OPEA, and that is something that you can take back to your company to explore if that's something you would want to do with your teams. I also have some bonus content that I will reserve the last maybe 10 minutes to go over. That stuff is new. It was just announced at our Intel Vision event this week, so stick around to hear about that. All right, so one of the biggest problems today is building and deploying GenAI applications is very complex, right? How do you start? Like, do we just start from a blank sheet? I don't think so. That's not a good idea. By the time we build something, it's probably outdated, right? And so what Intel has done is we have partnered with a lot of different software vendors, and these are like the people who are like experts in certain areas, like Docker, for example, or Hugging Face, right? So, or if we're working with vector databases, there's Redis. You know, all these different companies, they're doing something to enable Gen AI for developers and everyone in the industry. So rather than starting from scratch and from the ground up, what if we leverage all of the good work that these companies are using and use it to build our own Gen AI apps? That would be so much the learning curve would be so much easier, not as steep. And hence, instead of focusing on what framework to use, what language to use, let's focus on actually building the actual solution that we want. And most importantly, how do we build, deploy, customize it, and then scale it out? So that's where OPEA comes in. Open Platform for Enterprise AI. It's an open source project, part of the Linux Foundation, and Intel is one of the partners, but we've also partnered with all of these different software companies to build out Gen AI applications. So for today, let's start. We're going to do so on AWS using CloudFormation templates and using Elastic Kubernetes service. All right, so let's start. So the first thing I want to start is we're going to get access to our cluster. So this command here, what we need to do is it's going to use CloudFormation to initialize our stack. So let's say we go into your console here. I want you to search for CloudFormation, right? So go to CloudFormation. CloudFormation will take you over here. Yeah. So in that entire provisioning process that Vinny right here helped us do, it's already set up the entire environment, and it has like these different stacks. So we're actually for this workshop, we're going to go through each of these different stacks, including basic chat Q&A, show you guardrails, OpenSearch, and Bedrock. Those are the 4 I will show you today. So next, I would like you to go up to this let me make it bigger. Go to up here. There's like there's a Cloud Shell button. So click on that. You're going to get a console like this. So you can run directly from here. I don't really like it being half my screen only. So what I do is I just open in new browser tab. So if you click on this button on the right, it gives you like a full window. And it's just much more user-friendly. You can see a lot more. Okay. And what you want to do is you're going to want to take that command right here and run it. So again, it's this command that I copied from module 1, deploy chat Q&A. step 1, examine cluster resources. Yeah, so what this is going to do is it's going to start initializing the stack for chat Q&A. Yeah, so previously this OPEA chat Q&A stack was in review in progress. Now it actually created. So what that does is, another thing I wanted to show you is go ahead and search Elastic Kubernetes service. Elastic Kubernetes service will take you here, and you should be able to see that the cluster was created. Looks like this. I'm gonna pause, or this will probably take maybe 5 minutes or so. Does anyone have issues getting to that step, or at least running the first command? Created? Oh, I forgot to use the mic. No, I already have a mic. Oh, past the mic. Okay. I see.
So it's already says it's created 13 hours ago, and the command didn't do anything.
Command didn't do anything. Oh, it's not supposed to have any. It's not supposed to show anything. It's going to run a lot of the things in the background. But to confirm that it actually did something, if you go to Amazon Elastic Kubernetes service, you should, and then on the left-hand side, click on clusters. You should be able to see OPEA EKS cluster. Yeah. This will probably take about 5 minutes or so to run. So in the meantime, let me explain a little bit about the OPEA architecture. So today, let's say we want to build a RAG chat Q&A pipeline, right? Obviously, there's so many building blocks. How do you even start? The good thing about OPEA is that it already has the architecture set in place. And it has all of these different building blocks, which we call microservices. And essentially, you're just running and deploying these services. Let's say, for us, we have one for doing LLM. So that one is to use, this one right here, LLM is used for doing text generation. We have other services, including one to create the embeddings from, let's say we want to upload a document so that I can do retrieval. One to create embeddings, one to do data prep as well, and then we're going to use a Redis vector database to store that information. We'll have a re-ranker for when we do retrieval. We need to re-rank the different documents or information that is most aligned with the user query before we actually pass it to the LLM microservice to do inference. There's also a UI, basic UI that I'll show you. And and then from a user, we access it through a load balancer provided by AWS, and it goes through a VPC to do so. And so with this entire architecture here, it provides you something that is secure, reliable, and also gives you high performance. All right, so in this next part, we will look at the types of resources that we have in our cluster. To do that, the command is kubectl get pods. So if you go back to your Cloud Shell, let me see if I can make this bigger. You run kubectl get pods. You should be able to, okay, it looks like it's still initializing. Let's take a look. Re-sign into all of these. console. Config. Oh, right, I missed a step, sorry. Yeah, I missed a step. You do need to, that step. Oh, is there a step that's missing? One sec. Let's see. I remember. No, you shouldn't have to. It's supposed to create that for you in the part of the stack. See? Are you getting the same issue? Oh. That is sources. No, it's the default namespace. This first one's the default namespace.
Hey, there is a getting setup step. So you need to set up your Kubernetes cluster. There's a step to set up your Kubernetes cluster.
Yes.
Yeah, that step. You need to do that step. That's before this.
Right.
Yeah, the getting set up.
This
the left
one?
side. Yeah, just above your module 1. No. Towards the left.
Oh.
Yeah, you need to set up your Kubernetes cluster.
Oh, my bad. Yeah, I forgot this part. I was getting ahead of myself. Okay, yeah. So yeah, using Workshop Studio, we do need to go here. We do need to set up your cluster, run this command. Then you should get some output, and then now it should work. So get nodes should work. Okay. And then kubectl get pods. You should also get something like this. You do need to ensure that every single service is in the ready state. I'm not sure if this will work if it's not running. All right, so let's go back here. So just in case, if one of your pods is not working, you can run a command called kubectl delete pod. When you delete that pod, Kubernetes will automatically respawn it. That's one of the benefits of using Kubernetes. Like your services will there'll always be the services that are running. So it won't ever be down. Kube control, make sure it's running. I'm gonna restart mine because it's not ready. Or maybe I'll wait. 10 minutes is a long time. back here. All right, so how OPEA, the architecture for OPEA works is there's essentially 3 components. At the very bottom is a microservice. So these microservices, think of it as an entirely packaged building block that does a specific function, including text generation, embedding creation, retrieval, etc. A megaservice uses at least one of these microservices to build an entire pipeline. So for a chat Q&A, we're leveraging all of these different microservices together. And lastly, the gateway is an entry point for you as the user or your customers to access and talk to and to make some sort of request, and then it will automatically route to the appropriate microservice to carry out your request. All right. I'm going to skip some of these steps. The main thing I want you to go next is inside your AWS account, I want you to go to load balancers, or go to EC2 first. Go to EC2, and then on the very bottom, click on load balancers. You should be able to see a chat Q&A ingress load balancer here. And note down the DNS name. Yeah, because this DNS name is going to be used in how we're going to interact with those different microservices. And next, you're going to want to run this curl command, but you need to replace this with your load balancer DNS. What we're doing here is we are sending a input prompt to it. We're going to ask it, what was the revenue of Nike in 2023? And then we're just testing to see that the entire pipeline is working. So I'm going to put this here. I'll do it here. Here's my command. Here is my DNS. And when you run this curl command in your Cloud Shell, just make double check. Oops. Okay. Oh, I need to fix that. You'll probably need to add a backslash, otherwise the Cloud Shell doesn't like pasting extra lines. Here. Oh, it didn't work. Okay. Again. Okay, all right. Okay, thank you. The formatting doesn't like me today. Are people able to run this command? Or also struggling like me? You able to run it? Yeah. All right, let's do this. All right, finally. Finally got something working. Yeah, so this is just a test that your text text generation pipeline is working. Yeah, right now you see, because we're running on a console, it's just printing out character by character. But you can see from the answer, it actually says, as of now, the revenue of Nike for 2023 has not been reported. The latest available information from their 2022 fiscal year, where they reported revenue, was $4 billion. Okay, so it looks like so oftentimes when working with chatbots and models, the model doesn't have the most recent information, and hence it gives you incorrect answers. And that's where RAG can come in, where you can actually put in the most relevant and newest information, and then your chatbot will be able to retrieve that information and augment the prompt before generating the answer. So let's do that. Moving forward, this is the entire pipeline. So what we want to do so this is like a blueprint that you can use to get started building any RAG pipeline. You can have your additional documents that you want. It will feed it through the data prep service, and also what it does, it creates creates chunks out of these documents, and each chunk is converted into embeddings. These embeddings are stored into a vector database. When a user sends an query, your text is also converted into embeddings, and then it does retrieval from the vector database to see which of those vectors most closely align with the question you're asking. It does re-ranking by figuring out which ones are the most relevant before finally going through the LLM microservice to do text generation to give you your final answer. So right now we're going to test the embedding, one of the embedding microservices. So the next command here is you're going to want to access the Nginx pod. So you want to copy this command and then replace it with the chat Q&A Nginx pod. So I'm going to copy this here first. To get your pod name, what you do is go into your Cloud Shell and type kubectl get pods. You will be able to see one that's called chat Q&A Nginx deployment. So you want to copy this into this command right here. And when we run that, you'll notice that now I'm in root at chat Q&A Nginx deployment. So I'm inside this particular Docker container. And the next command right here, it's going to use a curl command to interface with the chat Q&A text embeddings interface microservice. And it's going to, and the input is what is deep learning. Let's run that in the console right here. We should be able to get a lot of different numbers because embeddings is nothing but a vector of a whole bunch of numbers. But let's say we want to do something more interesting. Let's say we want to upload a document. In this example, we're going to upload a document of Nike's revenue report from 2023 so that we can answer that question correctly. So let's run this next command right here. This is going to download that document. After that, the next curl command here, it uses the data prep microservice to actually upload the doc into the vector database. Right, so this will take about maybe 30 seconds or so. You should be able to get a confirmation saying that data preparation succeeded. This data prep also has other features. For example, you can get the actual file. You can also upload a web link instead. You can also use get file or get web link. So you can work with both PDF files or websites in order to improve your knowledge base. Okay, so I got data preparation succeeded. If you run the next command here to get the file, it should tell me that it does have the Nike 10K 2023.pdf file. That's how you confirm that it works. All right, so now that we've uploaded, let's do, I want to skip. So in the essence of time, I'm going to skip to another part. Let's do, let's see. Yeah, the rest of the instructions give you more information about re-ranking. You can look at that later. But the most important thing is once you go to, you can skip over to this section about LLM microservice. And here we're just going to rerun that same command, but it will actually give us the correct answer because now it will actually leverage that information. Oh, did not work. Still a strong year. As a number did not represent sports. Not been reported. Yeah, this is the expected output. So it's different. Previously, I was saying like it didn't have any information. It was only referring to information from 2022. But this one, it actually leveraged some information from that document to give you a different response. That is the whole point for this example here. But I also want to show you like what it looks like in the UI. So to access the UI, you can go to the load balancer over here. Go back. Go to the load balancer and access the DNS name. And you will want to replace it with, enter in this URL with your load balancer, and then you should get a UI that looks something like this. So here, actually, this is the UI. You can see that we actually have the document loaded over here. if you ask it a question, what is the revenue of Nike in 2023? Here you can see it actually references a lot of that information to give you the correct answer, which is 51.2 billion. So see, now that it knows that because the original model doesn't have the answer, it's able to leverage this entire RAG pipeline with new information to get the right answer. But that's loading documents is one thing. I also want to show you quickly how you can also load websites. One example is it doesn't know what OPEA is. It says the term OPEA is not mentioned in the provided context. It seems to be an acronym or abbreviation. Okay, so completely wrong. In here, if you scroll down in this module, it gives you a link to the OPEA website. Just for reference, it looks something like this. So you can replace this with any website you want. Basically, this is our documentation for OPEA. And yeah, clearly it tells you OPEA stands for Open Platform for Enterprise AI. And over here, you can do a paste link. Confirm. It will upload it. And then if I ask the same question, it will give me the correct answer. Question? Do you have a mic? Who has the mic?
Paste link work for YouTube videos where it could transcribe and just get the context out of it?
Good question. I have not tried it myself. Why don't you try that? Try that and tell me. But yeah, it depends on the microservice. The microservice does support different data formats, PDF, mainly text. Video, that one is another question. That one I don't have the answer to right now. All right. So at the point, yeah. So that's the first module right here. This is how you set up a very basic chat Q&A RAG pipeline. And you notice that we didn't do any code. All we're doing is just deployment here. And why this is so good is now you can actually customize your solution. Maybe you want to go inside those different microservices and tailor the solution to your own needs. So you can focus on that rather than having to reinvent the wheel of building this entire architecture. So for the sake of time, I'm going to kind of speed through OpenSearch and Bedrock using my previously configured environment. So out of curiosity, how many of you have used or heard of OpenSearch? Only a couple, so just a couple, so not many. Okay, so what is OpenSearch, right? So OpenSearch, it's a search analytics and vector database solution. It's a service that's provided by AWS. And it's an alternate, and what we're doing here is it's an alternative to the Redis vector database that we've been working with. And so we understand that a lot of customers might already be using these existing database or even LLM services from AWS. We want to make it easier for developers to actually integrate these services into OPEA, into their entire chat Q&A pipeline. So that's the purpose of this module right here. So how are we changing the architecture itself? Well, the only two pieces that will be different will be the data prep and the retriever. two things. We're essentially swapping out those two microservices that we had from the original chat Q&A with OpenSearch. If you do, yeah, so I will skip the part where you set up. But it's very similar to the chat Q&A one. You run the CloudFormation, execute change set instead, but you're specifying a different stack, the OPEA OpenSearch stack instead. Once you set that up, you do a get pods with the OpenSearch namespace. You see different microservices that are launched. So if I go to my own terminal, here. The main difference here is we now have another microservice called OpenSearch cluster. What else do I want to show you? Yeah, and then there are some commands in the tutorial that shows you how you port forward. We want to port forward the OpenSearch microservice, so we actually use it. What we're trying to do is doing the same thing in the previous example, which is upload a document. So if I run this one, port forward, query, and then skip this one. Here I'm going to upload a document to OpenSearch. Okay. The next command will be running data prep. Oh wait, we need to pour forward and then data prep. I think I already ran that. Yeah, I already ran that. Okay. Operation succeed. Pour forward. You need to port forward and then run the curl command. Upload a file. Yeah. So for me, I already uploaded it previously. That's why it gave me a different message. But essentially, how you leverage these microservices is you specify that port that the service is running on, and then use a curl command with your inputs. Yeah, I think that's really the gist of it. Question? Can you pass the mic to him?
Any limitations running it on Elasticsearch? If you run it on
the question is,
Elasticsearch
any limitations on running on Elasticsearch
instead of OpenSearch?
instead of OpenSearch? Not that I know of. So in OpenSearch, there's another page right here. It gives you some more advanced features of actually doing how it does the retrieval process. There is both lexical queries and also semantic, which is like with vector queries. So you can read about this to play around with it, whether you want. Lexical means like taking the literal meaning from the documents, versus semantic will use convert them into vectors and use the nearest neighbor method to figure out the query. Or you can even play around with hybrid search with OpenSearch. So here, it uses a mix of both lexical and semantic with vector search to get a different answer. So these are some of the things that you can play around with. The third module I want to refer to is Bedrock. How many of you are using Bedrock? So not many of you. Yeah, Bedrock, essentially it's a LLM service. It gives you access to a lot of, for example, a lot of different models that are hosted on AWS, so you can take full advantage of that repository. And so how this is different from the regular chat Q&A is we're swapping out that TGI LLM service with Bedrock. So the whole point is like this OPA architecture, it allows you to swap out these different building blocks with different services that you may already be using or you're probably developing. Yeah, so for the Bedrock part, there is once you can go to Bedrock right here. And on Bedrock, on the very bottom left side, there's a tab called Model Access. Like this is where you can enable, you have to actually enable the models in order to use them. In the tutorial itself, it asks you to get access to Claude, Claude 3 HiQ. Let me show you in this one. The model access is where you get access to these models. And once you have access to it, then you can actually use them in your pipeline. On Bedrock, go to model access. This tutorial asks you to get the Claude 3 HiQ. Here I'm just checking that I have Bedrock in my Bedrock namespace. So you can see, I know in this list, I no longer have that TGI LLM service. Instead, I have Chat Q&A Bedrock deployment. So that's how it replaces it. And so when I run Chat Q&A with this, it's going to use the Bedrock service to do my text generation instead. To access the UI, it tells you to go to the load balancers. So I'm going to go to the load balancers right here. Oh, there it is. The most important thing is the DNS name. So this one right here, it's the same UI, but let me see. Yep, same UI. But now we're actually using the Bedrock LLM service. So let's say if I ask a question, what is OPEA? So same thing, but you notice it's actually a little different from previously. It's actually even faster. We can do the same thing where we upload a web link or document so that it can answer the question correctly. This link. Ask the same question. And now it's correct answer. So the whole point of this exercise is to show that this entire architecture is already available. It's easy to swap out different microservices to services that you want to use, including those that Amazon provide. OpenSearch, Elasticsearch, Bedrock, anything that you want. So that you don't have to recreate this entire pipeline yourself. All right. That's all of the workshop stuff I wanted to show. I did promise some bonus content at the end. So the question is like, let's say this helps you build a chat Q&A or GenAI application. Well, then where does it go from there, right? Because it still might, if you're going to scale out your solution, it's going to be very, very expensive. And so at Intel Vision, Intel actually announced something new called the Intel AI for Enterprise Inference. So let me start from here. So this is new stuff. This is showing? Not showing. Okay. Okay, now it's showing. Okay. Yeah, so the AI inference market is expected to grow a lot in the coming years, much more than training. And so how can we prepare ourselves for the next few years? How do we ensure that our costs don't overrun so that we can actually make the right decisions so that we can grow in the long run? So when it comes to adopting inference, like whether you're hosting on-prem or on the cloud, there's always cost and there's also infrastructure management. And so what Intel has done is that they're enabling enterprises to adopt a more low-cost inference with what's called OpenAI compatible APIs. So what does that look like? Well, let's say you have an entire stack from your hardware to middleware drivers to the models that you're using to like the actual applications, right? And so what we have provided is we partnered with you can partner with our different cloud service providers, AWS, IBM Cloud, where they actually host the hardware, and all you have to do is you just take an endpoint from the endpoint of like a service that's running, and use that to do your text generation and other applications. It removes a lot of the overhead of actually owning your entire system and doing a lot of the infrastructure maintenance because all of those services are hosted on that single node that you have in the cloud. And when you're using a lot of different services like Kubernetes, et cetera, it automates that entire setup process for you. We understand a lot of customers are using OpenAI compatible APIs. That's why this inference as a service is made to support that as well. So you don't have to change the way in which you are deploying your models out there. What are the benefits? So you don't have to worry about setting up your server from scratch or your containers, allowing you to get faster time to solution, and hence also reduce costs in the long run. It's also secure because in order to access these resources, we've integrated key cloak authentication so that you can control who gets access to your resources. I'll skip this one. This one. Yeah, so this is the most important diagram I want to show you. So let's say you have your server with the endpoint. Basically that cluster, it supports any model that you're already running with. Whether it's Llama or Mistral, DeepSeed, any model. You host this on a single platform. All you need is a key. So this identity and access management, it has key cloak set up. So all you have to do is once you have that key, you can access this inference endpoint to get access to using any model that you want on this hardware platform. And this hardware platform can be Xeon, it can be Gaudi, it can be anything you want. The whole point is you don't have to worry about setting this up on every single machine. You set it up on a single node or single cluster, and that handles all of the heavy lifting for you when you actually run your different applications. This slide here is just showing you if you want to use the OpenAI environment, you just need, it's the same way that you usually access. You just need your API key and also a base URL. Base URL is it specifies the inference endpoint of the service that's running on your specific server. This last one I wanted to show you is, so this is the entire pipeline that we went over today, a RAG chat Q&A pipeline. And the thing is, so this blue box right here, this inference part, this is the part where the inference APIs can play a role in. Because here, all you have to do is, here you can swap it out and you can use Xeon, you can use Gaudi, you can really customize the inference API that you want based on your own needs. So that is all I wanted to show you today. So just as a summary, recap. So OPEA, Open Platform for Enterprise AI, open source project, has different building blocks of microservices that allow you to build your GenAI apps with a lot less code. So components is one. There's also actual examples. Chat Q&A is one of them. The other examples include, we have one for agent Q&A. We have AI avatar chatbot, document summarization, image generation. Different examples that are very popular today that leverage these microservices, so you can start there without having to start from scratch. It works on different cloud service providers, including AWS. We simplified that entire deployment process using CloudFormation and the Elastic Kubernetes service. And finally, to scale out your solutions, you can use this new concept called inference APIs. So that's all I have prepared for you today. Yeah, does anyone have any questions?
When you said you can switch Xeon or any other hardware, where does that fit in here?
Where does it fit in?
Into this?
Yes. So for Xeon and Gaudi specifically, Gaudi is mainly used to work with the largest models out there, which is for text generation purposes. So you would swap out Xeon for Gaudi at the blue box, just the blue box right there. All the other components still run on Xeon.
Okay, thanks.
Do you have any metrics for the cost of running this? How do we need to think about, where the cost components are going to be? Is it the data? Is it the usage? Anything like that?
You're asking, do I have any data on the actual
Do you have any
cost?
metrics that we can use to try to estimate the cost of building something and running something like this application?
Usually the cost of running is just based on whatever instance you're using from the cloud.
What are the factors that increase the cost more than others? Do you have any sense for that? I mean, if I leave this, right, I build this, I leave it running for a week or a month, right? What should I expect in terms of costs? Do you have any guidelines or any metrics on that? It's okay if you don't.
Yeah, let me get back to you on that one.
Okay.
Intel has any on the training side as well?
Okay, so the question is, do we have any training side? As of right now, our focus is more on inference. Yes. What else can I say? That is all I can say for now. Gaudi, so Gaudi is an alternative to GPUs. And we actually released some performance numbers on MLPerf, or no, sorry, not MLPerf. But Gaudi 3 is a direct competitor to H100 and 200, showing very good TCO, price performance. So Gaudi can be used for training as well. We do have documentation and a full software stack and other libraries, including Optimum Habana, for you to run Hugging Face models with Gaudi to do both training and inference.
Sorry, one last question. Since you said this is open source, right? Does that mean if I have NIM operator running Kubernetes clusters, will I be able to serve, because all of them are GPU, NVIDIA-based endpoints?
Can you rephrase the question?
Because this is open source, right? Does that mean, does it support non-Intel?
Oh, you're asking if that OPEA project supports
Ecosystems.
non-Intel?
Yeah.
The answer is yes.
Okay.
Yes. So every example, so actually I can show you that right now. So let's say if I go to, so this GitHub repository is for GenAI examples. So we just ran chat Q&A, which is over here. If you go into, so here, Docker Compose, it shows there's a folder for Intel, there's a folder for AMD, there's also a folder for NVIDIA. Yeah, I also invite you to go to OPEA project GenAI examples. These are those end-to-end pipelines that leverage those different microservices. I think AI agent is going to be super relevant in the coming years. So definitely take a look at that one because, yeah, we already know that even building a basic RAG chat Q&A pipeline is very complex. Agent, I'm pretty sure is the same thing. What framework do I use? How do I start? How do I test it? If it's something already available and open source and free to use, why not try it? Right? Why not stand on the shoulders of giants and try it out? But I will also say the agent Q&A, if you're interested, it's built on the Llama, I think, built with LangChain filmwork. Yes. We have other ones like code generation, document summarization, multimodal Q&A, video Q&A. So a lot of different examples for you to get started with. And if you are interested in like deploying this on other examples on CloudFormation, how it works is every single in CloudFormation, if you go into one particular stack, it gives you a template, and it's using this template where it provisions the entire stack. So this is where you can take as a starting point. And these templates are available on the GitHub as well. So you can take these templates, and you can use it to deploy those other GenAI examples as well. Any other questions? Okay, well, if no other questions, hey, thank you for sticking around to the end of this workshop.